Hi everybody, here is our last little video for scatter plots. This particular video is going to have us look at what's called a model line, which means that the book is asking us to look at a pre-created line, not necessarily one that fits the data, but more, and one that I believe should be there, but it's one that fits with a hypothesis that a scientist would have or whatever else. So we are going to be doing a project in 2 days that's going to last for 4 days, and it's about problem 4.1. And so this one is sort of alluding to that project that we're about to do. But essentially in that project, we look for a relationship between height versus arm span. So how tall a person is versus how long their arms are from tip of their middle finger to tip of their middle finger. The scatter plot here shows data from a group of middle school students. To start out with, we're going to draw a model line that goes through this point 130, 130, and 190, 190. Essentially from one corner of this graph to another corner of this graph. And as we draw that line, we are then going to use this line to sort of make predictions on things and sort of compare what we see in the data versus what we actually see on the graph. So we've drawn a line that would essentially extend out in both directions, and then we can now use this line to describe what we see here. So in this relationship, essentially a person came out and said, I believe that there is a direct relationship between height and arm span. And with this height versus arm span, we should be able to see if you are a certain height, you should have exactly that same arm span. So this person's name was Vitruvius, and that's what our project's all about. But essentially, we need to look at this data and say, okay, what does it mean for people who would potentially lie here or people who lie here, and talk about people who lie exactly on the line. So first, we've drawn this line. Now we're going to use this line to describe the relationship between height and arm span. Essentially, if we look at this line, what can we say about the students that are on here? And what we can say is, typically a person is about the same height as their arm span, but I am seeing a little bit more data above in terms of arm span. So our arms are typically a little bit longer overall in this middle school data than being perfectly like 130, 130, 140, 140, 150, 150, that sort of thing. So essentially people have slightly longer arms. It looks like, oop, my daughter's crying, just a moment. Yes, please. My husband's gonna go get her. All right, so she's not gonna just scream, don't worry. All right, so typically a person who lies on this line is sort of a little bit lower in this actual data of people. So it looks like people are have just a little bit longer arms than they are tall, given that this line kind of is shifted down from the data just the slightest bit. So now write an equation for this line using height versus A for arm span. Essentially, what is this equation here for this line? If I were to think about this, we could talk about slope. So we know the slope formula is slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so we can look at the differences in our y variables versus our x variables. So we could say 190 minus 130 over 190 minus 130 gets me 60 over 60, which equals 1. So my slope of a line, y equals mx plus b, my slope of a line is going to be 1. Now I just need to figure out my y-intercept. I have this point, 130, 130, that lies on this line, so I can just put this information in here and solve for my b value. So I can say 130 is equal to 1 times 130 plus b. So I get 130 is equal to 130 plus b. What value can I add to 130 to still get 130? That means b has to be equal to 0. So my equation for this line would just simply be, and I have y versus x's, but I could write the same thing for the arm span is equal to 1 times the height plus 0, or technically I could also just write height, or arm span is equal to height based on that line. Now, last but not least, we need to be able to answer some of these questions that are down here. It says, what is true about the relationship between height and arm span for points on the graph? If points are on the model line, if they're actually lying on that model line, we'd say that these people have a perfect height to arm span ratio. Essentially, their height and arm span are the exact same values. They're the exact same lengths. Points above this model line, points up here, or even these points that are just right above it, points up there mean that the arms are longer than they are tall. And then points below the model line, we would say these people, their arms are shorter than they are tall. Kind of interesting. So if I were to put these in perspective, I'd say like this would be someone who's maybe has just longer arms, and because I am in this group, I would say like I'm a little bit more like a monkey, and that monkeys have longer arms than they are tall. So I'm shaped more like a monkey, and that my arms are longer. Mine are substantially longer than I am tall. And arms that are shorter are a little bit more T-Rex. So they have like short little arms compared to how tall they are. So we have T-Rex people, perfect humans, and then perfect humans in terms of height versus arm span. I should put the caveat. And then people who have longer arms, which are kind of our monkey people. Nice and fun way to look at some data, and at the same time we can also see that this trend line is maybe not the best trend line for this particular set of data. Thank you for watching. Start working on your must-do practice problems, and if you have any questions, do not hesitate to ask before you take the exit pass. Thank you for watching. Bye.